For example 3.4, we're going to start in chapter 3. So we're looking at finding the equation of a tangent for a given function when we're given a x coordinate. So the first steps to this process, I've written some notes here on the right hand side of the screen. We're just going to follow through those steps each time. So similar to the steps that I would have given you in topics 1 and 2, we need to firstly derive the function. So y equals cosine of x would have a derivative of dy on dx equal to derivative of cos is minus sine of x. So we've done step number 1. In this case we're not given the y coordinate, so we need to also find what y is equal to. So I'm going to change the notation there to find f of 0. That would be equal to, remembering y is up here, cosine of 0 is 1. So we'll put that in brackets just to show what we've done there. So cosine of 0 is 1. So we now have the point 0, 1, as well as our derivative function. So at this stage, once we've got those two things, we can use either method, whatever you're most confident in. So obviously this one we need to substitute y1 and x1 in with our given point, and our slope that we found above here of equal to, which we haven't yet found, sorry, we need to find the slope at the given point. So let's add that into this concept. If we want to find the slope at 0, we're going to substitute that into this function, the slope function. Sine of 0 we know is 0, so we can write that in pretty straightforward. So here, where we're looking at the cosine function, remembering our cosine function starts at its maximum at the y-axis, we would expect our line to have that maximum, meaning that our slope would be 0. So a tangent should have a horizontal line of y equals that value. So we can use that information, which is why I would probably work with this equation, making it a little bit easier. If we write our equation, we know that y is equal to 1. Our slope was 0, so it doesn't matter what x is, but we'll put that in as well, plus the c value. In this case, c must then equal 1. So our equation of our tangent will just be y equals 1. So following the steps, we've been able to get the equation of the tangent, in this case being the horizontal line of y equals 1. For our second example, we're going to scroll down a little bit here. We've got a little bit more of a complex function, but still following the same process. We're going to find the derivative, so dy on dx, derivative of that. Because we've got sine of a function, we're going to have to make use of the chain rule. The chain rule giving us derivative of sine is cosine of 2x, and then we will multiply that by the derivative of the function, so timesing that by 2. Again, simplifying, dy on dx is going to equal 4 cosine of the function 2x. So we've found the slope. We can go ahead and find what that slope is equal to. So substituting in the point, or the x coordinate of pi over 4. Again, changing the notation just so we can read it a little bit easier. F dashed of pi over 4 is going to equal 4 cosine of 2 lots of that. When we simplify, 2 lots of pi on 4 is just pi on 2. So we're trying to find what cosine of pi on 2 is. Again, the function of cosine starts at its maximum, and by pi on 2 would be at 0. So our slope, f dashed at that point is going to be 4 lots of 0, again giving us 0 for the slope. So in both examples, it appears that we're at some sort of stationary point. If we've achieved the value of m, we then need to just find what the c value is, and to do that we need to have known what y, so we go to step 2. For step 2, we can substitute in the x coordinate into the original function. So y is equal to 2 lots of sine 2 times pi on 4, we said was pi on 2. So I'm just going to substitute that in straight away. Sine of pi on 2 is at a maximum, so that would be equal to 1. And our result is going to be y equals 2 lots of 1, so y equals 2. Like we did above, we could substitute in the slope and the x-intercept, the x value, but as we see here, we don't need to do that because our slope is again 0, so it would just cancel out. So our second equation would be y equals 2.